Good morning to everyone. This is Anisha. Today we are going to see the second chapter of grade 9, that is polynomials. This is a very interesting topic. We can study very easily throughout this. And we can go into the session. See, I have given the contents as first slide. Here it consists of introduction part, types of polynomials, picture a view about it, and what is meant by degree zero of a polynomial, and I have given some algebraic identities and division of a polynomial, think tanker, and finally query board. Okay, what is meant by polynomial? A polynomial is very simple. It consists of both the variables and coefficients. It's a combined operation of variables and coefficients, which involves all kinds of basic four operations, which excludes divisions, addition, subtraction, multiplication. Okay. So, see here in the definition I have given, a polynomial is an expression consisting of variables and coefficients that involves only the operations of addition, subtraction, and multiplication with non-negative exponents. For example, see here x squared minus 3x plus 6, which is a quadratic polynomial. See here, this expression consists of a coefficient. See here, it consists of a coefficients of variables minus 3, and see here, this x square has a coefficient of 1 and x has a coefficient of minus 3 and also a constant 6. So this is a polynomial expression which consists of variables and coefficients with constants, and since the degree is 2, we say as a quadratic polynomial. I will explain in the later slides what is meant by degree, okay? So don't be panic. These are some terms which we come across these polynomial sessions, that is monomial, binomial, and trinomial. Finally, polynomial. Okay, what is mean by monomial, binomial, trinomial, etc.? We can see it. The types of polynomials are monomial, binomial, and trinomial. Monomial is simple. It's a polynomial with just only one term. And binomial is a polynomial consists of only two terms, and trinomial is a polynomial consists of only three terms. That I have written as a monomial is a polynomial with one term, a binomial is a polynomial which is a sum of two monomials, a trinomial consists of three terms, that is of three monomials. Okay, see here for monomial example is just 3x is a example, just 3x is a monomial. And 4xy is also a monomial. 3x is a separate monomial and 4xy is a separate monomial example. Okay. For binomial example is 2x plus 5 is a binomial expression. So here it consists of two terms. 2x is one term and 5 is one term. So total two terms. And for trinomial, 3x plus 5y plus 7z is a trinomial example. So here it consists of three terms. Okay. So it's a trinomial expression. This is a pictorial view about this monomial, binomial, and trinomial. See here, single wheel, monomial, and two wheels, binomial, and three wheel, it is a trinomial. See here, per cycle, we have a pictorial representations of this. Then, what is meant by degree? The degree of a polynomial is the highest power of a canonical expression, or simply we can say in a polynomial, the highest power possessed, that is the degree. This is the definition. The degree of a polynomial is the highest degree of its terms when the polynomial is expressed in canonical form. The degree of the term is sum of the exponents of the variables that appear in it. In a polynomial expression, the power which is having the highest power in the canonical form is said to be the degree. Let us go through briefly with that example. And also you must know, whenever a polynomial with degree 0, we say it as constant polynomial, okay? Whenever you have a polynomial with degree 0, you say it as a constant polynomial. And degree 1, if you have means, we say as linear polynomial. And with the degree 2, it's called as quadratic polynomial. And with degree 3, we say as cubic polynomial. And with degree 4, we say as quadratic, or commonly we use as biquadratic. Okay. Okay, see here. Here I have explained with two examples. Uh, x square minus 4x power 4 plus x power 6. See, in this polynomial expression, this first term x has the power of 2, and the second term of x has the power 4, and the third term x has the power of 6. Here, the highest power is obviously 6. So the degree of this polynomial is 6. And in the next example, see here, x y power 4 plus x power 4 y power 4 plus 12. And here how you need to see find the degree is, see here above the x the power is 1, and above the power y has a power of 4. So totally this term has a power of 1 plus 4, which is equal to 5. And the second term has, see, the power of x has 4, and the power of y has 4. So totally the power of this second term is 4 plus 4 equal to 8. So this is the, obviously this is the highest power, and this is the degree of the this polynomial. So 8 is the degree of this polynomial. Okay. Next, we are going to see what is meant by zero of a polynomial. Zero of the polynomial is, we have to put, for example, when you take a polynomial, the value which satisfies the polynomial is said to be zero. The whatever the value you put in this polynomial, it must satisfy. That value is obviously said as a zero of a polynomial. The zero of a polynomial is defined as, for any real value x for which the value of the polynomial becomes zero, it satisfies the value satisfies that particular polynomial, that is mean by zero of a polynomial. For example, I take 2x minus 2 as a polynomial. Okay, I take 2x minus 2 as a polynomial. Obviously, what value if you here you put becomes the polynomial satisfies you need to see. This 2x minus 2 will become 0. For what value it will become, the 2x minus 2 becomes 0 means, if you put 1 in the place of x, or you put x equal to 1, what obviously it happens, p of 1 equal to 2 into 1 minus 2, which is 2 minus 2, which is equal to 0. So this value 1 satisfies this polynomial. The p of x becomes 0. So the value, the 0 of this polynomial is 1. Here are some examples. Find the 0 of the polynomial in each of the following cases. P of x equal to x plus 5. P of x equal to x plus 5. We have to find the 0 of the polynomial. To find the 0 of the polynomial, we put p of x equal to 0 and finally find x. This is the technique you need to follow it. For finding a 0 of a particular polynomial, we have to equate that particular polynomial to 0, and finally we have to find the value of x. So here, p of x equal to 0 means that is x plus 5 equal to 0. So here plus 5 becomes minus 5 to the next side. So obviously x equal to minus 5, which is the 0 of the polynomial. Find the 0 of the polynomial p of x equal to 2x plus 1. The same procedure repeats. For finding the 0 of the polynomial, we have to equate that particular polynomial to 0 and find the x. Okay, so p of x equal to 0 means 2x plus 1 equal to 0. So first of all, put this plus 1 to the next side, it becomes minus 1, that is 2x equal to minus 1. So when you take finally this 2 to the next side, it becomes division. So therefore x equal to minus 1 by 2. This is the 0 of the polynomial of 2x plus 1. Okay, next, check whether minus 2 and 2 are zeros of the polynomial x plus 2. We have to check it whether this minus 2 and 2 satisfies that polynomial x plus 2. So first of all, take polynomial p of x equal to x plus 2 and put x equal to minus 2 in place of put x equal to minus 2, the value minus 2 in the place of x. So p of minus 2 equal to minus 2 plus 2, which is equal to 0. So obviously this minus 2 is the 0 of the polynomial. So again you check, put x equal to 2 in that place. So p of 2 equal to 2 plus 2, which is equal to 4, which is not equal to 0. So this x equal to 2 is not a 0 of a polynomial. So minus 2 is only the 0 of the polynomial, but 2 cannot be the 0 of the polynomial. Here I have given 13 some algebraic identities, which you can go through this slide, and whatever formula identity you need to study, you can go through it. By this, using identities, we have to solve so many problems. It will be very useful if you go through and study these algebraic identities. So I have given one slide for it. You can go through it. Okay, use and simplify using algebraic identities. By using that algebraic identities, we need to solve these problems. First problem is x plus 3 into x plus 3. So you two times it's there. So I have written x plus 3 the whole square. So you can use of it this formula a plus b the whole square equal to a square plus 2ab plus b square. So here using that formula, x square plus 2 into x into 3 plus 3 square. So in place of a, you have to put x, and in place of b, you have to put 3. And using applying that formula, finally you will get x square plus 6x plus 9. The second problem is 2y plus 5 into 2y plus 5. Two times it repeats. So equal to 2y plus 5 the whole square. The same formula only, a plus b the whole square equal to a square plus 2ab plus b square. So in place of a you put 2y, and in place of b you put 5. So 2y the whole square plus 2 into 2y into 5 plus 5 whole square. Finally you can simplify and you will get equal to 4y square plus 20y plus 25. The third problem is 2a minus 7 into 2a minus 7. It's also two times repeats. So 2a minus 7 the whole square, but the formula identity is a minus b the whole square is equal to a square minus 2ab plus b square. In place of a, you put 2a, and in place of b, you put 7. Using this identity, you have to use it of 2a the whole square minus 2 into 2a into 7 plus 7 square. Finally, we'll get 4a square minus 28a plus 49. Next, minus 2 by 3 p square q into 5 by 4 pq square into 5 pqr. Yeah, to just multiply, ordinary multiplication only. I am taking out the coefficient of numbers separately, and the other terms separately. Minus 2 by 3 into 5 by 4 into 5. Only the coefficient of numbers I have taken separately first of all. And after that, sorry, and after that, taking this terms separately, p square q into pq square into pqr. Then this 3 will be cancelled out. So on this for 2 table you can cancel this. So here it goes 1 and 4 becomes 2. So finally we come across with minus 5 by 2, and how many p terms are there? P square into p into p. So total p power 4 and q into q square into q. So q power 4 and only one r is there, r. So final answer is minus 5 by 2 p power 4 q power 4 into r. And the final last example of this slide is a minus 7ab into minus 3aq into minus 2 by 7 ab square. Here also same procedure, taking the numbers first of all, minus 7 into minus 3 into minus 2 by 7 into ab into a cube into ab square. Then finally this 7 and 7 will be cancelling off. So minus into minus into minus, that is minus into minus plus, plus into minus minus. So minus is given, and 3 into 2 6. 7 7 will be cancelling off. And how many a's are there? A into a cube into a. So a power 5 and b into b square, b cube. Okay. So final answer is minus 6 a power 5 b cube. Here then 9, the next example is 9x plus 2y plus z the whole square. Here the identity which we are using is a plus b plus c the whole square. A plus b plus c the whole square identity, you can go through that algebraic identity slide and you can study it. The formula is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. See here, in place of a you have to put 9x, in place of b you have to put 2y, in place of c you have to put z. So a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Okay. So finally, you have to, after simplification, you will get this final answer. The same thing for the next example also. 3x plus 2y minus z the whole square. A plus b plus c the whole square. Formula is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. See here, in place of a you have to put 3x. In place of b you have to put 2y. In place of c you have to put minus z. Okay. So a square 3x plus in the whole square plus 2y the whole square plus minus z the whole square plus 2 into 3x into 2y, that is 2 into ab plus 2 into 2y into minus z, that is 2 into bc plus 2 into 3x into minus z plus 2 into ca. So final answer is 9x square plus 4y square plus z square plus 12xy minus 4yz minus 6x. Okay. Okay, now we can go into the next slide. Division of polynomials. So here you have to divide two types of polynomials. Two polynomials you have to divide. This is more or less similar to ordinary division, but some similar techniques you have to follow for this division of dividing the polynomials. See here, x cubed minus 3x square plus 3x minus 2. When you divide this by the term another polynomial x minus 2, what you have to do is take the first term of this coefficient x cubed divided by the first term of the divisor polynomial x. Okay. So here the first term of this polynomial is x cubed and the divisor polynomial first term is x. You have to divide. So x cubed by x equal to x square. That term will becomes the answer to the quotient part. So here you have to put x square. Okay. Then finally you have to multiply this x square to the divisor. X square into x equal to x cube you have to put here, and x square into minus 2 equal to minus 2x square. Okay, then as usual multiplication division, and so here plus sign is there, so it becomes minus. Here minus sign is there, so it becomes plus. So plus x cube and minus x cube cancel off, and minus 3x square and plus 2x square, it becomes minus plus. So the highest number sign will becomes comes here minus. So minus into plus is minus, so it yeah, just subtract minus 3x square plus 2x square is minus x square. Then take the next two terms down, 3x minus 2. Okay, 3x minus 2 I have taken down. So now you have to see the first term of this polynomial, minus x square, and first term of the divisor x. You have to divide it, minus x square by x, which is equal to minus x. You have to put this minus x in the coefficient, sorry, quotient, and multiply this minus x with the divisor. Minus x in the x, it's minus x square, and minus x minus 2 plus 2x. Okay, then here minus sign is there, the sign changes automatically plus. Here plus is there, so it changes into minus. So minus plus it cancel off, and plus 3x minus 2x it becomes x. Then take this minus 2 again down. So x minus 2. Take the first term of this polynomial x and the first term of the divisor polynomial x. So x by x is equal to 1, and put that plus 1 to the quotient side, and plus 1 into x equal to x, and plus 1 into minus 2 equal to minus 2, and the sign automatically changes here. For plus it becomes minus, for minus it becomes plus, and totally it cancel off. The remainder left out with 0, and the quotient of this polynomial, division of polynomials, is left is with the x square minus x plus 1. And see here the second another one problem I have given, x power 4 plus 0 x cube minus 3x square plus 4x plus 5 divided by x square minus x plus 1. The same procedure only. Take the first term of the polynomial x power 4 divided by first term of the divisor polynomial x square. So x power 4 divided by x square means it is x square. Put that x square in the quotient side, and now you multiply this x square with the divisor. X square into x square, x power 4, x square into minus x cube, x square into 1 plus x square. Then sign, automatically the sign changes, plus into minus. So here the sign is plus, it changes into minus, and minus it changes into plus, here plus it changes into minus. These both terms, plus x4 and minus x power 4, cancel off, and plus 0 x cube minus plus x cube becomes x cube, and minus 3x square minus x square becomes minus 4x square, and take these two terms down, plus 4x plus 5. And see here, take the first term of the polynomial x cube divided by the first term of the divisor polynomial x square. So x cube by x square is x. So plus x I have written here. So plus x you multiply with the divisor, x into x square equal to x cube, and x into minus x equal to minus x square, and x into 1 equal to plus x. So sign automatically changes, plus into minus, minus into plus, and again plus into minus. So cancelling these two, x plus x cube and minus x cube, and minus 4x square plus x square is equal to minus 3x square, and plus 4x minus x equal to plus 3x, and drop this 5 down. So taking the first term of the polynomial, minus 3x square divided by plus 1, divided by plus 1, sorry, we have to take this first term of the polynomial minus 3x square divided by the first term of the divisor polynomial, that is x square. So minus 3x square divided by x square is equal to minus 3. You have to put this minus 3 here. Here minus 3 is given. Sorry, here plus 5 is there. It's not plus 5, it's minus 3. Okay, so multiplying that minus 3 here to divisor, minus 3 into x square equal to minus 3x square, and minus 3 into minus x equal to plus 3x, and minus 3 into plus 1 equal to minus 3. And the sign automatically changes, minus to plus, plus to minus, minus to plus. So minus 3x square plus 3x square goes off, and plus 3x minus 3x goes on, and plus 5 and plus 3 is equal to 8. So the remainder is 8, and the quotient is x square plus x and minus 3. This plus 5 is not there, ma. Minus 3, okay? It's a careless mistake I have put up, okay? This is a think tangle board. You have to think it off. What is the resultant polynomial when x is multiplied to a quadratic polynomial? What is the resultant polynomial when x is multiplied to a quadratic polynomial? You have to think it off. What is a quadratic polynomial? And when you multiply with this, with that particular polynomial with x, what is the resultant polynomial? You have to think it off. This is a simple one word think tangle question. Okay. And the second, my question is, when cubic polynomial is divided by a linear polynomial, name the resultant polynomial in terms of degree. In a cubic polynomial, you have to take it off, and you have to divide that particular cubic polynomial by linear polynomial. Name the resultant polynomial in terms of degree. Okay, think it off. Take about 2 minutes time, and you yourself find it out the answer. I have given the answers in the next slide. We can go through it. So for my first question, what is the resultant polynomial when x is multiplied to a quadratic polynomial? I take a quadratic polynomial x square minus 2x plus 5. When you multiply with this x, see here you will get x cube minus 2x square plus 5x. When you multiply with this quadratic polynomial, you get a cubic polynomial, okay, in terms of degrees. My second question is, when cubic polynomial is divided by a linear polynomial, name the resultant polynomial in terms of degree. So I take a cubic polynomial, x cube minus 3x square plus 5x minus 1. Let x be a linear polynomial. When I divide it with the cubic polynomial, we get x square minus 3x plus 5 minus 1 by x. See here, this is obviously a quadratic polynomial. If you have any queries, you can ask and you can comment it, okay? I hope this session will be very interesting one for you, and hope you have understood this very clearly. Thank you for watching. Thank you guys.